Hi everyone, welcome to Luso's tutoring on Math 2011 Engineering Maths. Here you got my emails in case you want to contact me concerning what I did in this video. Okay. This video I will be doing tutorial 15, chapter 1. I'll be doing tutorial 15, chapter 1 of calculus. Okay. Now, I'm going to start straight with the first question. First question is and then the thing here, it says that find the complete general solution of D operator equations below. Okay. Now, I won't do the complementary solution because we did that on the previous video on tutorial 13. We did that. So what I will ask you to do for every solution, I'm only gonna do the particular solution, but for every particular solution, for you to determine to give the complete solution of the functions, you will have to say y, where y represent the complete solution of the function is equals to yp, which is the particular solution, plus yc, which is the complementary solution. But I'm only gonna do yp because we did yc on the previous video. Okay. Now a goes by d plus 2 multiplied by d minus 1 squared is equals to e to the power minus t. Okay. Now if you have to check this function here, is in the form pd is equals to e to the power alpha t. Okay. Now this is how we're gonna do this. This is how we're gonna solve it. We're gonna oh, here there should be, we must have y here. Okay. We're gonna solve y by doing something like this. We're gonna say y is equals to 1 over p, and where there is d, we substitute d by alpha, and then e to the power alpha t, and then this will be our solution. Okay. But it depends. If alpha, when we substitute alpha and we get 0, then we have to do something else. Okay. I'll do that question on the other video, not this one, because tutorial 15 doesn't have where the alpha it gives 0. Okay. Now solving this question here using this, we're gonna say y is equals to 1 over d plus 2 multiplied by d minus 1 e to the power of minus t. Okay. Now we are going to substitute alpha. Here you can see that alpha is -1, so this becomes 1 over, where there is d, we put alpha. Alpha is equals to -1. Okay, so we're going to say minus 1 plus 2 multiply by, oh, there is square here, minus 1 all squared e to the power of minus t. Okay. Now we solve that. So when we add this, we get +1, and then when we add this and square it, we get positive 4. So our solution is e to the power minus t over 4. Okay, this is not the solution for this is not the complete solution. This is the particular solution of the function. Please, now you have to add this value, you have to add this to the complementary solution of the corresponding question in tutorial 13 to get the complete solution of the question. Okay, now I'm gonna go to question B. I think I'll just have to squeeze it here by the side. I'm economizing. Though it seems small, but I'll squeeze it. Okay, B goes by d squared multiplied by d minus 2 cubed y is equals to e to the power of t. Okay, seems like it's working. Okay, now we're gonna do what we did on the previous example. Yp is equals to 1 over d squared multiplied by d minus 2 cubed e to the power of t. Okay, going forth, when we check this out, we realize that our alpha is equals to 1. So where there is d, we're gonna put 1. Okay, so this becomes 1 over 1 squared multiplied by 1 minus 2 cubed. Okay, e to the power of t. Okay, and then when we solve this, we find that this is 1, and then 1 minus 2 is minus 1, minus 1 cubed is minus 1. So our solution becomes negative e to the power of t. Okay, it's negative e to the power of t. Yeah, that was question A and B. Now going to C. Goes by C. Okay, C is d cubed. This is a weird cube. C is d cubed. Oh, what's wrong with me? D cubed plus 2d plus d squared minus d minus 1 operating on y is equals to t. Okay, yeah, now remember our aim is always to write this operator in the form 1 over 1 plus c. Okay, now we're gonna transform this operator into something like this. Okay, now the first step, we're gonna say, okay, yp, always yp, is equals to 1 over d cubed plus d squared minus d minus 1 multiplied by t. Okay, now we want to make this one positive, and then I'm gonna factor out negative so that 1 becomes positive, and then we're gonna do the trick we learned. Okay, so this is gonna be 1 over negative -1 plus d minus d cubed minus d squared, okay, multiplied by t. Okay, yeah, that is that. And then this is equals to this is going to be equals to -1 multiplied by 1 minus d minus d cubed minus d squared plus whatever follows, and this is multiplied by t. Note that I stopped. I did not continue to like square and then cube and then all that, because I realized that the highest power of t is 1, so only one derivative can be taken, which is this one, and then the rest will be useless because they will give us 0. Okay, so this is equals to, so you're gonna say t multiplied by 1, we get -1 multiplied by t, and then t the first derivative of t is equals to 1. So let me put a negative here, and then the first derivative of t is equals to 1, and put a 1 here. Okay, and then the third derivative of t is 0, so yeah, it ends here. And then this is equals to, when we are to multiply everything here, we're gonna find something like a 1 minus t. Okay, and this is the answer for the particular solution of the question. Okay, now going forth and doing to d, solving d. I just hope d will fit on this small space. If it doesn't fit, I will make a plan. Okay, now d goes by I'll say, okay, let me write what they wrote there is d squared over dt squared minus 1 all squared operating on y is equals to t cubed. Okay, remember we said d over dt is equals to d. Okay, but not this d for differential operator. Okay, now you're gonna write this as d squared minus 1 all squared, okay, is equals to t cubed. Okay, now when we work that out, we find that operating on y. Okay, this can be written as d to the power of 4 minus 2d squared plus 1 operating on y is equals to t cubed. Okay, and then y is given by 1 over 1 plus d to the power of 4 minus 2d squared, okay, t cubed multiplied by t cubed. Okay, I'll just gonna come here. Okay, from here we go there. Now we're gonna do what we are famous with. Gonna say we're gonna say, okay, gonna say 1 minus d to the power of 4 minus 2d squared minus 2d squared, and then plus what follows, and then multiply by t to the cube. Note that I stopped here because if I'm to continue, remember when I continue, I'm gonna have something like if I'm to continue, I'm gonna have something like d4 minus 2d squared all squared. So you can see that the highest power is going to be 8 and 6 and 4, which all going to give us 0. So that's why I'm stopping here. Okay, if you had to take this one, all of the derivative here, all of the derivatives here, they're going to give us 0, and then I'm gonna stop right on this one. Okay, now this gonna, okay, it's yp, it's yp here, not yp, and then this yp is equals to this, and then this is equals to t cubed minus the four derivatives of, we take 4 derivatives of t cubed, we get 0 because we're gonna have first one, we're gonna have 3t squared, and then the second one we're gonna have 6t, and then the third one we're gonna have 6, and then the fourth one we're gonna have 0. So it's 0 for this one, and then we minus 2 is a constant, and then we take 2 derivatives of t cubed. So remember, this was the first derivative and this was the second derivative, so we're just gonna say 6t, put 6t here. Okay, now our solution becomes something like, our solution becomes, this is equals to 12t plus t cubed, which is the particular solution of this question here, question D of tutorial 15. Okay, that was it for this tutorial. Check out new videos on the next material. Okay, cheers.